okay? And then come back. All right. So I drew the first two. So you're working these out. Your first step is identify the shape. Okay. Sorry, that's not the best cylinder. But so in the first one, we've got a cylinder. A cylinder is a circle on top and a circle on bottom connected. Okay. Looks like a Coke can, a Pringles can, anything like that. And so if you see a cylinder, you need to go to the formula sheet and write down the formula for a cylinder. Pi times r squared times height. Now, if you remember when we were doing the area of circles, area is pi r squared. Pi r squared. So the only difference between area and volume, area of a circle, and volume of a cylinder is this third dimension of height. And that's what I want you to think of. I want you to see the circle. So basically what we're doing here is we're finding the area of the circle at the top, and then we're dragging it, that third dimension, multiplying it times the height, okay? So if you remember, in the formula pi r squared, r stands for radius. The radius of a circle is from the center of the circle to the edge, all right? And what you may notice in number one is that this 10 meters is drawn all the way across the circle. So the first thing we need to do is realize that that's not the radius, that's the diameter. Cut it in half to get the radius. Pi is pi. The radius is 5, radius squared, times the height. Now is where we're bringing this dimension in, which is giving us the volume measurement. Okay, so pi times 5 squared times 8. Let's figure out what that is. Here's the pi button on my calculator. Times 5 squared times 8. 628.318. So we'll call it 0.32. 628.32. This is a meter measurement. So it's cubic meters. Okay? Now let's go back to the sheet. I believe, okay, this is one that does not have answers. Does not have answers. So you're just gonna have to take my word for it. 628.32 cubic meters would be the volume of this cylinder. Okay. All right. Number two. Go ahead and erase this. Get that out of here. Number two looks like this. Again, not the best drawing on my part. I'll try and draw the next one's a little better. Recognize the shape, which is a rectangular prism. This is one on the formula sheet that's not listed. They expect you to know this, okay? But kind of like what I was talking about with the cylinder, we can really see all these volume problems the same, which is, if you think about that base or even the top, okay? It's a rectangle. So if we find the area of that rectangle and then multiply it times the third dimension, drag it down, that's our volume. That's our third dimension, three-dimensional space measurement, okay? So 11 times 8, 11 by 8 is what this top one is. 11 by 8 is 88. 88, but then 16 centimeters worth. So drag down times 16. 88 times 16 is going to be the volume of this. So let's Take a look at the calculator. 88 times 16 equals 1408. 1,408. These are listed in centimeters, so we're talking about cubic centimeters. You can write that as centimeters to the third power. Okay, that would be the volume of that box. Let's go back to our worksheet. Okay, so I don't think that you all are going to have trouble with volume because you're all pretty good, and so should be easy to understand. Just find the formula, fill it in with your information. Okay, so why don't you take a look at number 3? Pause the video, go ahead and work it out, and then come back. Okay. All right, so hopefully you were able to figure that problem out. I've got it written down here. So remember, the first thing you need to do is identify the shape. Hopefully you were able to see this is a cylinder. Looks a little bit different than the last one because this one's laying over on its side. Makes no difference, okay? Here's the circle. There's where it's been stretched. So cylinder, formula for a cylinder is pi r squared times height. Now you may say, how could this be the height? Well, it could be if I lifted the can up and set it on its base. So you got to be flexible. Just kind of try to see that third dimension as just the third dimension. So we're going to start with the circle, which is the pi r squared. Pi 28, what you may notice in this one is it's only showing half the circle from the center to the edge, which is what the radius is. So we're going to use 28. Squared times the height. Again, here is the height, 60. Okay, so let's take a look at that. Go to my calculator. So pi, let me clear this first. Pi times the radius times 28 squared times 60 equals 147,780.52. We'll just call it 0.5. Cubic inches. Hopefully you got that part. Let me just, this seems like a big number. I'm going to double check my math there. Pi times 28 squared times 60. Yeah, I think it's right. Okay. So there it is. Again, it's inches to the third power, cubic inches, 147,780. Hopefully that's what you got. Let's go back to the worksheet. All right, number 4. Number 4 looks like a ball, right? Number 4 is a sphere. That's officially what it is. So what I want you to do, go to the reference sheet, find the formula and write it down. Then I want you to try to fill the formula in and work through it. It might be a little bit tough because you got to deal with the fraction 4/3. So let's see what you can do. Then go ahead and come back to the video, okay? Go ahead and do that. All right, so here's our problem. Spheres can be kind of hard to draw, but there's my best, okay? So there's my sphere. Notice when it comes to spheres, we only need one number. We only need one number. The rest of the formula is part of the formula, or the rest of the measurement is part of the formula. So 4/3 is always going to be part of it. Pi is always going to be part of it. We just need the r, which is the radius. Again, radius is from the center to the edge. So the 9 is the radius. plug that in, to the third power. All right, so let's see what happens. If we were at school, you would have a calculator that handles fractions. You wouldn't necessarily have to know the fraction work to do it. I don't know what calculator you guys are working with, so let's just see what mine has. Okay, I'm using a calculator from the laptop, so we're going to give it a try. We need to do 4/3 times pi r to the third power. So I'm going to start with pi r to the third power. Let me clear that. I don't think I did that right. Pi times the radius to the third power. Guess I'm just going to do times 9 times 9 times 9. You might have to do that as well. Pi times r to the third power. Now, to do 4/3, I'm just going to take this number, I'm going to multiply it by 4, and then divide it by 3. Okay, that's the same as times 4/3. Times the top number, but then divided by the bottom. So we have this multiplied by 4, but then divided by 3. All right, so that seemed a little bit complicated, but there's my answer. 86,339.299, so let's just call that 0.3. All right, we'll come back to the screen here. 86,339.3. This is volume, so it's always third power. So that's cubic feet. All right, so just to review what I did there, I first did this part. So I'm dealing with a calculator that doesn't have fractions, okay? So I first did pi times 9 times 9 times 9, which is what 9 to the third power means. Mine won't do third power either. It'll only do second power. And so I started there, pi times 9 times 9 times 9. Then I needed to multiply that times 4/3. So I multiplied it by 4, divided by 3. Okay, and that's how I dealt with that problem with a basic calculator. Pi times 9 times 9 times 9. And then times the 4/3, I did times 4, but then basically divided by 3. That's how you do that, okay? That's probably the toughest problem you're going to have is a sphere. And you may not even get one. I think you're guaranteed to get a cylinder and probably a pyramid. If you get a sphere, it's going to be tough, but that'd be how you can do it. We'll practice some more. So let's go back to our sheet. Lost that sheet. All right, so as I said just a second ago, I think you're going to get a pyramid. So here's an example of a pyramid. Pyramids can actually have different shapes at the bottom. It could be a square pyramid, as that's what this one is. If you look at the bottom, it's 18 by 18. It's got a square for a base. They don't have to be a square, though. It could be a rectangle. The base could be 18 by 14. Or it could even be like a triangular base. Okay? Regardless of what the base is, we need to realize that a pyramid, regardless of what the base looks like, always falls under this same formula. Let's look at it. 1/3 big B times H. The big B means area of the base. So when you have a pyramid, as in this problem, the first thing you do is find the area of the base. All right. So why don't you go ahead and draw this out and first find the area of the base. All right.